Arden's theorem. So what is that theorem about that? Given a DFA, convert into a regular expression. Given a DFA, convert into a regular expression. Let us given a DFA with two states. This is the final state and initial state. On input A, self loop. On input B goes to the state Q2, and Q2 state on input B goes to same Q2 state. So from Q2 there is a transition to Q1 state on input A. So what is this theorem speak about? Let us P, Q, R are the regular expression then R is equal to Q plus RP, then we can write R is equal to QP star. So let us go for the step 1. Write equation of each state so equation for initial state one of the term will be epsilon. Epsilon. So what is that equation here? We can write here that is Q1 is equal to epsilon plus Q1 A plus Q2. Simple answer that all the incident edges from the state are coming into this. So let us see, this is an incident edge coming from the Q1 state. This is another incident edge coming from the Q2 state on input A. So this is the equation number 1. So equation for the equation 2, so Q2, so what are the terms here coming here? We can write one is called Q2B plus, this is one Q2B plus, we can write here Q1A, Q1B. So what is that idea? That is input from Q1 on input B it goes to the Q2 state. From Q2 state on input B it is come to the Q2 state. So this is the equation number 2. What we are going to do that? We have to step number 2. So we will use substitution method. Use the substitution methods to find the equation of final state. Equation of the final state. Okay. So what is the idea here? If you see that equation Q2, okay, we can write here it is Q1B plus Q2B, and this is the form called Q, this is R and this is P, this is equal to R. Hence we can write here that is Q2 is equal to Q1B and B star. So R is equal to QP star. R is equal to QP star. So this is the Q and this is the P and it's star. So this is the equation number 3. Now substitute Q2 in Q1 as in equation of substitute Q2 in equation Q1. Equation 1. So what will happen that is Q1 is equal to epsilon plus Q1 A, right, and this is Q2 A. Now substitute this one, that is equal to Q1 equal to epsilon plus Q1 A plus Q1 B star. If you take common from the second and third term, so what we are going to get here, that is equal to Q1 A plus B star. Now you can see this equation here. This is R, this is Q, this is R, and this is P. So hence we can write here, hence we can write here Q1 is equal to epsilon A plus B star. Okay, so in which equation we are going to substitute this one? We are going to substitute, look at here, one of the things here, what I did here, I have substituted Q2 in the place of Q2, Q1 B star. But we are also forgetting that there is also an A, right? So when you are taking common Q1 here, it is A plus B star A, right? Hence we can write here Q1 is equal to epsilon A plus B star A, it's a whole star. And you know that epsilon is an identity element closure under concatenation. Okay, so we can write here Q1 is equal to A plus B star A whole star. So this is, so A plus B star A whole star is the regular expression of given DFA. Next topic is that minimization of DFA using Myhill-Nerode theorem. To find a minimal equivalent DFA with minimum number of states. With a minimum number of states. This method uses, what it uses here? Table filling approach or a method to minimize a DFA. So this is the theorem. Let us discuss the steps. Step 1. Create all the pair of states. Better write create the pair of all the states. Create the pair of all the states. Step number 2. If we at the same time, I am coming back to that one also. mark, that is which you call the tick, all the pairs, mark all the pairs QA, QB, such that QA is a final state and QB is a non-final state. There is no questions whether we are talking about which one is the final and which is non-final. Please to bother on that. Step number 3. Mark all the on-mark pair QA, QB such that if transition of state Q on input X and transition of QB on input X is marked. Here X is a input symbol. Repeat the step 3 until no more marking is made. Step number 4, combine all the combine each on-mark pair to a single state. So let us have a diagram. Let us have a DFA figure for this one. Suppose we have 6 state Q0, Q1, Q2, Q3, Q4 and Q5. There are 6 states. Every state is a circle what we have to do that, and let us there are three final state, Q1, Q2 and Q5, and the transition from Q0 to Q1 on input 0, Q0 to Q2 on input 1. Similarly, Q1 on input 0 goes to the Q3, and on input 1 goes to the state Q4. Similarly, Q2 on input 0 goes to the Q4 state, and on input 1 it goes to Q3 state. Similarly, Q3 state on input 0, 1 goes to Q5 state, and Q4 on input 0, 1 goes to Q5 state, and Q5 state on input 0, 1 it is the self loop. So this is the given DFA. Step 1, there are how many pairs you can see here. We will make this table like this: Q0, Q1, Q2, Q3, Q4, Q5. Q0, Q1, Q2, Q3, Q4 and Q5. Look at this. There does not exist the same pair on the same states. Does not exist pair on same states. Example, Q5, Q5. It does not exist. So there are, if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 pairs of states. So how the pair looks like that? QA, comma, QB. Step number 2. Step number 2. What we have to do for that? Let us write the step number 2 here. So let us brief idea. What are the states here? All pair states. Are Q0, Q5, Q0, Q4, Q0, Q3, dot dot, etc. All these pair states are in this form. Step number 2, according to the proof of this. So what is the step number 2? What we are going to do? Step number 2. Marking stage. Marking the pair QA, QB. As I already told you that. So pair, all the marking pairs create the pair of all the states, marking pairs, so that one is final state, other one is called non-final state. So one is final, and other is non-final. Okay, now if you see this figure completely, here Q1 is the final state, Q2 is the final state, Q5 is the final state, Q1, Q2, and here it is exists. Now if you see that, we can, if you write this step 2 here, let us go quickly. Q0, Q1, Q2, Q3, Q4, Q5. So quickly browse that. So we can have like this: Q0, Q1, Q2, Q3, Q4, Q5. So this is the step 2. This. So now it is called the marking stage. So Q1 is the final state, Q2 is the final state, Q5 is the final state. So Q1, Q2. So now you mark it. So one is final, another is non-final. So we can tick here Q0, Q5, Q0, Q2, Q0, Q1, Q0, Q5, Q0, Q2, Q0, Q1. Similarly, in the second column, Q1, Q4, Q1, Q3. So who are all coming here? Q1, Q4, Q1, Q3. Now we will go to the third column. Q2, Q4, Q2, Q4, Q2, Q3, Q2, Q3, Q2, Q3. Similarly, come into the fourth column, Q3, Q5 and Q3, Q4. We cannot pair here. So we can see this are we can mark Q4 at the fifth column. You will find here, which is the fifth column here. So that is Q4, comma Q5. So you count all these marking state. So these are all the marking state. So step 2, table. If you write here, this is called table. Step 2, table 1. We can write here. Better to write here. This is table 1. This is table 2. Now table 3. Repeat this process. Look at this stage. All the now can we as per the theorem say that on mark pair, collect all on mark pair. So what are all the on mark pair? You can see here Q0, Q4, Q0, Q3, Q1. In the first column we find this Q1, Q5, Q1, Q2, second column, first column, and in third column we will find here Q2, Q5, and in fourth column you will find Q3, Q4, Q3, Q4, fourth column, Q4, Q5 is a marked state here. You can see count here 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So fourth column. So we got only collected all the on mark pairs. Now check for one after another. For that we have to construct the, let us rather than from the transition graph, okay, we can construct the table. For that we can see. So let us consider the transition table of the DFA. What is that one here? I can write here in a small space Q0, Q1, Q2, Q3, Q4, Q5. On input 0, on input 1. Q0, so this is the transition table of DFA meshing. So this is the transition table of the DFA machine. I hope you people have already seen this, how to construct the transition table, right? So let us check all the on-mark pair, correct all the on-pair. Now check or test the on-marked pair to become marked pair. So what is the idea? Let us take Q0, Q4. If you see that Q0, Q4, Q1, Q5 not allowed, because it is a Q1, Q5 is already, it is a on-mark pair. Q1, Q5 is a on-mark pair. So what is your idea? To make it is a mark, the transition should be mark pair of that, right? So Q0, Q4, can you mark it? You can see here transition of Q0 on input 0 goes to Q1, transition of Q4 on input 0 goes to Q5. So we have tested, so it is, let us check for also Q0 on input 1 is going to Q2, Q4 on input 1 is going to Q5. So all are the on paired. This is on paired, this is also on paired, hence Q0, Q4 is remain unmarked. Now let us go to we have checked here number 1, number 2, number 3, number 4, 5, 6. Check or test the on-mark pair which is the on-mark pair next to that, Q0, Q3. So you will see that Q0, 0, Q1, Q3, 0, Q5, Q1, Q5 on mark. Second one, Q0, 1, Q3, 1. Q01, Q01, Q2, Q31, Q5. So Q2, Q5 is on mark. Hence, it is on mark. Q0, Q3 remain unmarked. Test the unmarked pair Q1, Q5. Q1 on input 0, Q5 on input 0, Q1 on input 0, Q3, Q5 on input 0, Q5. So Q1, Q5, the pair is called Q3, Q5. Q3, Q5 is already marked. It is marked, hence Q1, Q5 is marked. So what we have to do that? In the step 3, actually let me go for the table 3. You can create one more table here. We can create one more table here. Q0, Q1, Q2, Q3, Q4, Q5. Q0, Q1, Q2, Q3, Q4, Q5. So table 3. So which are already marked here early. If you see this, these 3 in column 1 marked early in table 2. These are already marked. Now what we have marked here, from the table 3 we have constructed the table 3 here. We can see here that now we have marked here Q1, Q5. Q1, Q5 is marked here. Now let us test for pair, test the pair Q2, Q5. So Q2 on input 0, Q5 on input 0. Here it is no need to go for the test for the one transition, because once it is marked here, automatically we can mark this state, right? So now Q2 0, Q5 0. If you see this table here, Q2, Q5, Q2, or let us Q2 and Q5. Okay. So on 0, Q4, it is Q5. Q4, Q5 is already marked. hence so Q2 Q5 could be mark. So make it as mark now. So we have marked this one also. Fifth number, test the pair. Which is the pair left out here? 1, 2, 3, 4, and here one more pair. Test the pair that is called Q1, Q2. Now let us transition of Q1 on input 0, Q2 on input 0. If you see this transition here, Q1 on input 0, Q3, and Q2 on input 0, Q4. Similarly for 1 also, Q1 on input 1, Q4, Q2, Q3. So what we are getting here, Q1 on input 0, we are getting here Q3, and this is Q4. So it is on mark. Now Q3, Q4 is Q3, Q4 on mark. So we cannot do Q3, Q4 on mark. Now let us see the transition for 1. So what you can write here, here it is going to Q4, here it is going to Q3. You can check here, Q1 on input Q4, Q2 on input Q3. So Q3, Q4, hence Q1 is remain on mark. 6th number step, which is 1 is left out here, that is called Q3, Q4. Q3, Q4, test the pair on mark pair Q3, Q4. Let us check for Q3 on input 0, Q4 on input 0. If you see that this is going to Q5, this is going to Q5, Q3 on input 1, Q4 input 1 going to Q5, 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 Q5 does not exist. So pair Q3, Q4 remain on mark. Now repeat the step until no marking is made. In the table. Then which are all left out here? We can say that this is left out, this one is left out, Q1, Q5 is left out, Q0, Q3 is left out. Now it is already marked here, Q0 on mark here, and which one the next one, Q0, Q3, Q0, Q4, Q0, Q4, Q0, Q3, Q0 Q3 Q1 Q2 Q3 Q4. Repeat the steps for this one. Now what we have to do that? So Q0 Q4, number 1. Pair, test pair Q0 Q4. Q0 on input 0 transition, Q4 on input 0 transition, Q0 where it is going, Q1, Q4, Q5. Now Q1, Q5, you can see that in this figure Q1, Q5 is already marked, hence the pair Q0, Q4 is marked. So we can mark this pair here. Q0, Q4, this one, not this one here. So for that one we can test here. Similarly, Q0, Q3, second one, test pair Q0, Q3, Q0 on 0, Q3 on 0. You can see here Q0, 0, Q1, Q3, 0, Q5. Even Q4 also Q5 for that. So Q1, Q5 is pair, hence the pair Q0, Q3 is marked. So what we did here, you can see that this is also marked here. These two states are marked. So which are remaining left out here? Now third, test Q1, Q2. If you test the Q1, Q2, Q1 on input 0, Q2 on input 0, Q1 on input 0 is goes to Q3, and Q2 on input 0 it goes to Q4. So Q3, Q4 is on mark. Similarly, let us go for Q1 on input 1 transition, Q2 on input 1 transition. Again it is going to Q4, and Q2 on input 1 it is going to Q3. So it is a on mark transition. Hence Q1, Q2 remain on mark. Early table also it is on mark. Early iteration it was on marked. Now also it is become on mark. Test number, test the Q3, Q4, the sixth number one, Q3, test pair Q3, Q4, Q3 on input 0, Q4 on input 0, Q5, Q5 does not exist, Q5 pair, Q3 1, Q4 1, Q5, Q5 does not exist. Hence, Q3, Q4 remain unmarked. So we schedule all that. Finally, the last table which we have drawn here, this one Q1, Q2 pair, and this one Q3, Q4 pair remain unmarked. This is unmarked. This is unmarked. Step number 4. Go to the combine the unmarked pair states to a single state. That is Q1, Q2 become a single state, similarly pair Q3, Q4 is a single state, that is Q3, Q4 is a single state. All the remaining steps now redraw the DFA machine, keeping all transition So what will happen that now initial Q1 with the initial state is remain same. Q1, Q2 both were the final state, so let it be final state. Q3, Q4 is a single state as both are non-final state, so it became non-final state. Q5 is final state in this machine. Okay, it is the final state in the machine, so keep it as it is. This is the initial state, so make the transition as it is there. Q1 on input 0, it is going to Q1. Q1 on input 1, it is going to Q2. Similarly, Q1, Q2 on transition 0 and 1, it is goes to Q3, Q4. Q3, Q4 on input 0 and 1, it goes to Q5, and there is a loop here on input transition 0 and 1. So this is the minimized DFA machine constructed using Myhill-Nerode theorem.